pamozi ndi mtima umodzi. Tiyende pamozi ndi mtima umodzi. Oh, tiyende pamozi ndi mtima umodzi. 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 Oh, tiyende pamozi ndi mtima umodzi. Tiyende pamozi ndi mtima umodzi. Tiyende pamozi ndi mtima.
Hello everybody and welcome to MTN Teleschool. My name is Anton Samanenga. I'm pleased to be on this MTN platform to help you prepare for your final exams. We are going to revise with you a few questions from the 2017 Paper 2 General Certificate of Education past paper. As you join me live streaming, please remember to tag your friends and family so that they can also be able to join us. In my last session, I had some questions that we looked at from section A of paper 2, 2017 GCE, which was July paper. And thank you so much, Mlongo, for the comment that we need to spend some time on calculus. We are aware about that. And we can rest assure you that a colleague is coming on tomorrow to come and spend some more time on calculus. Right, thank you so much to all those that have joined us. Mwanza, Kavindula, Daisy, Mukuka Simeon also have joined us on this MTN Teleschool. Now let's go straight to our work. We are going to look at question number 9, which is on cubic functions. Question number 9 is on cubic functions, and cubic functions can be examined in two ways. You can either be given a cubic function, the equation or the function of the cubic function where you need to draw the graph, or they would have given you a graph already drawn and then ask you questions that follow. So in this paper, a graph was already drawn, and then they were asking you some questions from the already drawn graph. So the question reads, the diagram below shows the graph of y equals x cubed plus x squared minus 5x plus 3. So the function of this cubic function is y equals x cubed plus x squared minus 5x plus 3. I'm sure you're able to see it on your screen there. It has been beamed on the screen. Now, when you look at this question, there is a cubic function which has already been drawn on the graph paper. Earlier on, I said, say, a quadratic equation has two solutions, and when it's plotted on the Cartesian plane, it cuts the x-axis on 2 points. But for a cubic function, when plotted on the x or y plane, if we solve the cubic function, we are going to find 3 solutions. These solutions represent, or they stand for that when this graph is sketched on the x or y plane or the Cartesian plane, it is going to give us 3 points where it's going to cut the x-axis. So that is what you need to bear in mind. So like what I'm saying, I'm talking about this with a quadratic function. For example, if drawn, say parabola, it may either open upwards if this is, say, 1 and this is -1. So we can see that these are the points at which this parabola or the quadratic equation is cutting the x-axis. I earlier on alluded to the fact that with a quadratic equation, the highest power to which the variable is raised to is 2. And now with a cubic function, the highest power to which the variable is raised to is 3. But since the highest power in a parabola or quadratic function to which it's raised to is 2, that's why we are having this parabola opening up and cutting the x-axis on 2 points. Now, what about the cubic function? The cubic function we've been given, or maybe before we look at the one that we've been given, this is the x-axis, and this is the origin, and this is the y-axis. With a cubic function, when you are asked to solve the cubic function, it is going to give you 3 solutions. And those solutions represent that this graph or this function, when it is plotted on the x or y plane, it is going to cut the x-axis on 3 points. For example, you may have something like this. This is an example of a cubic function. So this point, and this point represents the solution of the cubic function given. So if this is -3, for example, and this is -1, and then this is 1, if we are to say, can you find the solution from the given graph, the solution of this cubic function that has been drawn here, we are going to say x is simply -3, or x simply -1, and x equals 1. That is basically what you need to look at. Now, when you look at the given cubic function, on the question, kindly look at the question on the screen, on your screen, excuse me. It looks something like this. I'm going to draw a sketch graph for this so that you may be able to follow. We have a graph that is looking something like this, the x-axis. Don't worry, this is just a sketch. On a graph paper, it comes out quite neat, so you don't need to worry so much. I'm sketching here. So we have the points 1 and 2 and also 3. We also have the point -1 and -2 and -3. Then we also have points going up to like 10, 20, and 30, somewhere there. So 10, 20, and 30. Just a sketch of the graph that has been given. And then we have a situation where the graph is passing through -3, like this, comes like this. Then it passes through this point. Please don't worry about my sketching. And then it goes up like that. That is the cubic function that we are talking about. But you may be able to see that if you use a graph paper, it will come out very smooth. Now, one may wonder to say the graph is not cutting the x-axis on 3 points, but only on 2 points, and that is at -3 and also at 1. So meaning that this cubic function has repeated roots or repeated solutions. At 1, it is turning at 1, meaning the values of x will be x equals -3 or x equals 1 and x equals 1 because it's a repeated root. It's still a cubic function even if it's not being seen touching the x-axis on 3 points. I hope you're able to follow from there how my explanation has been concerning this question on cubic functions. So now the question here states, use the graph to calculate an estimate of the gradient of the curve at the point 2 and 5. Use the graph to estimate the gradient of the curve at the point 2 and 5. 2,5. So we have 2,5, a point, and we want to use this graph to estimate the gradient of the curve. Now, earlier on, we also talked about gradient of a straight line at any point is the same. But in this case, the gradient of the curve is not equal to the gradient of a straight line at any point. It differs, but we can use the point that has been given and any other point that we can read on the graph to find the gradient of a straight line at that point that has been mentioned. So, here we go. We are saying we need to calculate an estimate of the gradient of the curve at the point 2 and 5. All right, so at the point 2 and 5, when you look at this diagram, We have 10 somewhere there. So 2 and 5 is somewhere here. That is where they want us to draw this, 2 and 5. So you can draw a line passing through that. This is just a sketch, passing a tangent, passing through this curve here at 2 and 5. Then it goes. So you have gotten this point, which is 2 and 5 here. So we need to read another point on the same line, which is 2 and 5, which you can clearly read. And if we draw this line properly on a graph paper, I'm just trying to show you how to go about it. Let's say this line is passing through 1 and 0, and then the other part is 2 and 5. Then it's possible that you can find the gradient of a straight line passing through that point using the formula that we've already used before in calculating the gradient of a straight line. So that is basically what you need to know. I'm just giving you tips or ideas on how to go about finding the gradient of the curve at the point 2, 5. Right, so let's move on now to the next part of the question. The next part of the question states, use the graph to solve the equation. So the equation given is y equals x cubed plus x squared minus 5x plus 3. You are not going into the idea of solving this whole given cubic function, maybe using factor theorem and all that stuff. They are saying use your graph to solve the equations. So the graph has already been drawn. Then they want to ask you to find the solutions of this graph. What do they mean here? What they simply mean here is, what are the points, the x point coordinates, where, or what are the points where the graph is cutting the x-axis? So when you look at this graph, it is passing through this point, which is very visible in the diagram. I think it's going to be beamed there. It's passing through -3, and then it also makes a turn at 1. So to answer question 9, equals 1. We are writing x equals 1 simply because it's a repeated root. So it's making a turn at 1, and that's why we have used the graph to solve the equation of the given cubic function. So you don't need, excuse me, to look at, to really panic to say, how am I going to solve it? Should I use remainder and factor theorem and all that stuff? No, you don't need to do that. You just simply look at the points where this graph is cutting the x-axis. Just pick those points and then you move on in that direction. Then you have no problem at all. Let's look at question part B. Excuse me. Question part B also states, use the graph to solve the equations x cubed plus x squared minus 5x plus 3 equals 5x. This is also very interesting. You can see that in that question, we have two graphs that are going to be drawn there. There are two graphs that are going to be drawn there. There is this graph of a cubic function that has already been drawn there. And there's also this graph of a linear function of 5x. So we can say the two graphs that have been merged together from this are y equals x cubed plus x squared minus 5x plus 3, and another graph is that of y equals 5x, which is a linear graph. So they have combined the two graphs, and then they are asking you to use the two graphs to solve the equation given. So you don't need to stress much here. All what you need to know is this graph has already been drawn. All what you need is also to draw the graph of y equals 5x. This is simply a linear equation. Y equals 5x. If you remember at grade 9 and grade 8, we also teach how to plot graphs of linear equation. So you are going to come up with a solution box. You are going to come up with a solution box, one for the x and the y coordinates. I think 2 points are enough for you to plot up this linear graph, or 3 points if you so wish. So what points are we going to pick here? When you look at the scale given, on the x-axis we are using 2 centimeters to represent 1 unit, and on the y-axis we are using 2 centimeters to represent 10 units. So kindly look again at the question there so that you can have an understanding of what I'm talking about. The scale that has been used to come up with this cubic function is that on the x-axis, 2 centimeters is representing 1 unit, and on the y-axis, 2 centimeters is representing 10 units. So now, you can come up with, if x is 0, what will be y? If x is 0, what will be y? We have picked on 0 as an arbitrary number. So you can pick on 0 and then move on into that direction. So if x is 0, what will be y? If x is 1, what will be y? If x is 2, what will be y? So we are going to replace these x values which we have found into the given equation so that we can be able to do what? To find the y values and plot this linear equation on the already plotted cubic function. That is what you need to do. Right, so if we say x is 0, we have the equation y equals 5, where there's x, we replace it with 0. So 5 times 0, we have y equals 0. So when x is 0, our y is also going to be what? 0. Now, what of if x is 1? If x is 1, we shall still do the same. Y equals 5, and then we put 1 here. 5 times 1, then our y is going to be what? 5. So here our y shall be 5. Again, we can deliberately say, let's even get the 2. If x is 2, we are saying y equals 5 and then 2 here. And if we say 5 times 2, we are going to have our y to be 10. So these 3 points are enough for us to come up with a straight line or a linear graph that can be plotted on the already drawn cubic function in order for us to solve it. So we have now the points 0 and 0, 1 and 5, 2 and 10. We can write them as coordinates so that we can easily follow. So this is going to be 0 and 0. Then we have 1 and 5. We also have 2 and 10. We are used to saying 0, 0, 1, 5, 2, 10, but it's the same language that we are using here. So having found the coordinates where this linear graph is going to pass, then we can draw it on the what? On the given graph. So the given graph is a sketch of what I drew there, but on the question, when you look at the question, it looks very smart and very clean. And if you're using the question, I think the graph paper is not going to be a problem at all. So we have ascertained that it's passing through 0 and 0. Then the other one is 1 and 5. 1 and 5. Then the other point is 2 and 10. 2 and 10. So we are going to plot these points on the x or y plane so that we are able to find this linear graph and how it's going to be fixed on the cubic function. So 0 and 0 is this point, which is the origin. Now we are plotting 1 and 5. Since this is 10 here, so 1 and 5 will be half of this, so 5 will be somewhere there. This is a sketch I'm trying to emphasize again. Students, they are out. If you use a graph, you are going to with the graph given, you'll be able to see clearly where 5 is going to be. So I've marked the point where 5 is going to be with this x so that you may be able to follow that we have another point there. Then the other point that we have is 2 and 10. So 2 and 10 is simply this point here. So now we can get a ruler and draw a straight line passing through these points like this. So I'm sure you're able to see that. Right, so having drawn those points, we are able to see that this cubic function, which I've already drawn here, which has already been drawn on the paper, and this linear function or linear graph, which I've already drawn, they are intersecting at this point and also at that point. These are the points of intersection here and there. I hope you're able to see. So when they say use the graph to solve the equations, they are asking you now in that second part of the question that the points of intersection of the cubic function and the linear function, that is where your solution lies. But how are you going to do it? You drop from here, draw dotted lines down there, and do the reading on the x-axis here. You also do the same here. You drop and do the reading on the x-axis here. So these points are the points of intersection which are of the required points on the graph. So you don't need even to stress. That is what you are expected to do in order for you to answer that question, which is question 9. So they are saying use your graph. You just need to do everything possible to look at the graph and see where the point of intersection. So like the first one, we simply looked at the point where these cubic functions had cut the x-axis, which was this point 1 and negative 3. Then for the second one, we drew a linear graph, and the points of intersection of this linear graph and the cubic function here is what they are looking for. And we had to drop down to take the reading on x and also drop down to take the reading on x. So I'm simply trying to demonstrate how you can go about answering this question. Please find time to practice it. Sit with your graph paper like the way the question is. Then try and see how you can come up with what I'm trying to talk about here. Right. We move on, and we're also grateful that Davis Mwewai is following us. Solomon Jovu is also following us, and they are so glad that they're able to join us on the MTN Teleschool. Please keep those comments coming, and we are very grateful for the support that you are giving to this program. We continue to part 3, where they are asking us to calculate an estimate of the area bounded by the curve. Now, since my first diagram, I had already written a number of things there, I want to draw a sketch of this same question as it is. So I'm just going to pick on the major points. We have -1 here. We also have -2 here. We also have -3 here. And then we have 1 here. And we have a 2 here, and we have a 3 here. Great. I hope you're able to follow. Then we also have, this is our y-axis, and this is our x-axis. I don't want to leave anyone behind. Solomon Jovu, I hope you are following what we are doing here. Please have time to see what we are doing. Then we have 10 here, and 20 here. It's just a sketch of what has already been plotted in the question. Then we have 30. Then we continue to have -10 here, and -20, -30, like that, and this is the origin. Right. So now, let me quickly sketch this graph. I'll try and sketch this graph. It's passing through -3, so it's going like this, and it comes like this. Then it makes a turning point at 1, so it goes like this. At 1, it's making a turning point, so it passes like this and goes something like that. I'm sure you're able to see that it's making a turning point at 1 here. Right. Now, Part 3, they are saying calculate an estimate of the area bounded by the curve x equals 0. So x equals 0 as an equation, x equals 0 as an equation is simply the y-axis. And y equals 0 is simply the x-axis. And they have also said calculate an estimate of the area bounded by the curve x equals 0, y equals 0, and x equals -2. So we have the questions x equals 0 is the y-axis, this is the x equals 0, that is the center of attraction here. And then we have y equals 0, y equals 0 is the x-axis, this is the y equals 0. So our interest is this y-axis and the x-axis. Then they have also mentioned another point, which is x equals -2. X equals -2 is the line that we draw that is passing through -2 there. So what is the area, the estimate area under this curve? So we have the area they are talking about is this area, then this curve, and this part and this part. This is what they are talking about. I'm sure you're able to see. This is the area. I'm going to shade it so thick so that you're able to see what we are talking about. So on your graph, you'll be able to realize that we can partition this area into two segments. So there is this segment and this segment. And these small segments form the shapes of a trapezium. So one way we can also find the area of this under this curve is to simply find the area of this trapezium, which we can say trapezium A and the trapezium B. When we add them together, then we are able to find the area, the estimate area bounded by the curve x equals 0, y equals 0, as well as y x equals what? -2. Now when you get back, we go back to the question, you will find that this height on your graph paper, when you calculate it properly, this is 9. So we can say this height is 9. But before I go to that, we know that the area of a trapezium is given by half, then A plus B, and then H, where H is the height. So in this case, our H is this, and we can make this as our A and this as our B. So what is this height? When you look at the graph given there, this height is half, and this is 9 plus, and the breadth there gives us 8, and the height is simply the distance from -1 to -2, which is the same as 1, and then we're going to have it 1 that way. So I'm sure you're able to follow what I'm trying to explain here. So you simply now add them, 9 plus 8, and that gives you 17. And if you say 17 divided by 2, 17 divided by 2 gives you the area of 8.5 square units, because area, the units is what? Square units. That is the area of trapezium A. Now we look at the area of trapezium B. We use the same formula, half equals A plus B, then the height. But you need also to pay attention here and say, what was our B in the first part will become our A, and this one becomes our B. But it doesn't matter. What is important is for you to come up with what they are really asking us to do. So we've already ascertained that this distance from here to there is 8. So we can say our A is 8 here, plus, then the distance from here to there, it's 1, 2, 3, and this is 3, and the height is still 1 like that. So from there we have 8 plus 3, that is 11, and if you say 11 divided by 2, you are going to get 5.5 square units. So the question states, calculate an estimate of the area bounded by the curve y equals bounded by the curve x equals 0. X equals 0, we've already ascertained that is the y is the y-axis, and y equals 0 is the x-axis, and then the value x equals -2. So what we are going to do is to simply now add the area of trapezium A and the area of trapezium B in order for us to find the area bounded by the curve between the lines that have already been talked about. So we're now simply going to say the area therefore equals A equals 8.5 plus 5.5. And when you add 5.5 to 8.5, what are you going to get? We are going to say 8.5, just a minute, 8.5 plus 5.5, and that gives you 14. So the area bounded, the estimate area bounded by that curve is 14 square units. That is what you just need to look at, and simply look at the question that has been given there. Thank you so much to Innocent Monga also, who has joined us and enjoying the program, and Solomon Jovu as well is following very carefully. We are very pleased and happy with those comments that are coming through. Please keep them coming on, and we'll be able to give you an update on when the next sessions are going to take place. Right, so now we move on to our next question, which is B. Next question is B. It says, find the equation of the tangent. Find the equation of the tangent to the curve y equals, a curve is y equals x squared minus 3x minus 4. I think at this moment you now understand why calculus was also introduced in the revised curriculum, because it gives you also an insight on when we talk about cubic functions and also parabolic functions, which are parabolas or quadratic functions of that nature. So how then do we find the equation of the tangent to the curve y equals x squared minus 3x minus 4 at the point, they have even specified, at the point x equals 2. So at the point x equals 2, as a coordinate, we can also write it as 2 and 0 there. You need to know that the point x equals 2 can also be written as 2 and 0. So now we move on. How do we find the equation of the tangent? The equation of the tangent is something which is just very simple. Those terms should not be able to scare you in calculus. What is a tangent? When we talk of a tangent, we are simply talking about a line that is touching a curve at one point. So we've been given the cubic function x squared minus 3x, x cubed, sorry, is x squared. Find the equation, find the equation of the tangent to the curve y equals x squared minus 3x and minus 4. So in order for us to find the tangent, the equation, this is the equation, we need to find the gradient. We have learned how to find the gradient. We said gradient equals y, the difference in y coordinates over the difference in x coordinate, and we've used this formula time and again to find the gradient of a straight line. But I want also to introduce you to another way of finding the gradient of, this is not a straight line, so we cannot use the formula for the gradient of a straight line to find the gradient. This is not a straight line. So we are going to use now differentiation, part of the calculus. We are going to differentiate this given equation with respect to x, so that we can find its tangent, its gradient. So we are going to say dy over dx equals x squared minus 3x minus 4. And when you look at that question, here 3x, x is also raised to power 1. And I already said to say x squared here, the coefficient of x squared is 1. So what we are going to do to differentiate this, I said earlier on that you do not need to memorize the formula. You just need to understand what you are doing. Sometimes in an exam, you get just mixed up on how to memorize a lot of formulas and the like. But what I'm trying to emphasize here is, please understand what is supposed to be done. If you can remember the formula, that is well and good. But if you can understand what is supposed to be done, then that is what makes things better. no memorizing, but understand. Because if you memorize, once a question is twisted, you are going to experience a blow to an extent whereby you are switched off in an exam and just get disoriented. So how do we differentiate x with dy, the function of y with respect to x? This power 2 will multiply this 1. So we are going to have 2x, but this power is losing 1. So we are going to have just 2x to the power 1, which is the same as 2x minus. The power to which this x is raised to is 1. So 1 multiplies this 3. We have negative 3, and we have negative 3. And this power is losing 1. So 1 minus 1, we have a 0 here. Any number raised to power 0 is 1. And 1 times 3 will simply give us 3. So we are going to have 2x minus 3 as the gradient of that given function. But then we've been told that we need to find the gradient at the point where x equals 2. So at the point where x equals 2, what is the gradient? At the point where x equals 2, we are going now to substitute this value of 2 into this gradient so that we find the actual gradient they are talking about. In this case, the gradient is in form of a linear equation, which is 2x minus 3. It's not a numerical value yet. So since they have specified a point where x equals 2, after differentiating that given function with respect to x, we found this gradient, which is 2x minus 3. Then we are going to replace this value there. So we are going to move on and say 2. Then we have a 2 here, then minus 3. And if we expand 2 times 2, we have 4 minus 3. And 4 minus 3 gives us 1. So now we are saying at the point 2, the gradient is what? 1. At the point 2, the gradient is 1. So now we are going to say, so the gradient of the tangent is 1. So we shall say, y, we have a point 2. I earlier on said this point is the same as 2.2 and 0. So gradient is the change in y divided by the change in x. So we get back now to like what we are doing with gradient of a straight line. So we can see that we have, this is our x coordinate and this is our y coordinate. And so we are going to say y minus another y value, which is 0, over x minus another x value, which is 2 here. And what was the gradient? The gradient we found was 1. Right. I hope you're able to follow there. So we are now going to simply cross multiply. We know that from y, if we take away 0, 0 is a friendly number. You remove it from a number, that number will remain the same. It's a faithful number. You remove it. If you force it to multiply to something, it will make something become 0. That's how interesting 0 is. So now we are going to say, if you say y minus 0, from y you remove 0. It's cy. So y times 1, we're going to have y equals, then 1 times, we're going to have 1, then x minus 2. We're cross multiplying here. So if we now expand this, we're going to say 1 times x, we have x, and 1 times this, we have minus 2. So that is the equation of the tangent. Like it is stated, find the equation of the tangent to the curve y equals x squared minus 3x minus 4 at the point. So right, this is what you're expected to do on cubic functions. Earlier on I said, well, sometimes they can give you a cubic function that you can draw a graph, or sometimes they'll bring an already drawn graph. Then you are expected to do what? To find answers from the given what? Cubic function. So for now we are going to pause for an ad break, and we'll be coming back in 2 minutes time to look at the other question. Please stay tuned. Thank you so much, Shambwe Maxwell Kabai, for joining us. We are happy that you can also avail yourself on MTN Teleschool. Thank you so much.
Rise up this morning, smile with the rising sun. 3 little birds pitch by my doorstep, singing sweet songs. I'll turn message to you. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Cause every little thing is gonna be alright.
How you use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you. Rise up this morning, smile with the rising sun. Three little birds pitch by my doorstep, singing sweet songs, our melodies pure and true, saying, this is my message to you. Singing, don't worry about a thing, 'cause every little thing is gonna be alright. Sing, don't worry about a thing, 'cause every little thing is gonna be alright. Cause every little thing is gonna be alright.
How you use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you.
Hello once again, welcome back to MTN Teleschool. Thank you so much for joining me. My name is Samanenga. Please, as I said earlier, tag your friends and family so that they can also join us in watching. And you can leave a comment also for us that we are able to see that you are following us and even where you're watching us from. Let's look at one of the questions, and that is question 11 in the 2017 paper 2 GCSE paper. And most of the questions in section B are graphical questions and they score a lot of marks. The other question that was on cubic function carries 12 marks, so 12 marks is a lot of marks that you cannot afford to miss in the final exam. I'm also going to look at another question that most of the students avoid in the final exam, and that is on linear programming. This question just requires a lot of understanding. You don't need to memorize. You need to understand what they are asking you to do. So let me read the question through with you. Question number 11. And the instruction which is given is that you're supposed to answer this question on a sheet of graph paper. So you need to have a graph paper with you. I hope in my next session I'm going to do much more elaboration on how to go about plotting the inequalities that we are going to come up with on the graph paper so that we can be able to do what? To find what is being asked in the question. So under linear programming, you are expected to come up with inequalities. You are also expected to come up to find the maximum profit which maybe that business may be able to make. So these are topics which can be applied in the real life situations. We are trying to move away from that type of mathematics where we just teach and it remains in a classroom situation and that is all. But we're trying to learn and then see how best we can apply in a real life situation. So these are practical questions that needs understanding whenever you want to do what? You want to answer them. So let's go through the question together. The question reads, Makwebo prepares 2 types of sausages. Makwebo prepared 2 types of sausages, Hungarian and beef, daily for sale. So Makwebo is a businesswoman or businessman. We don't know whether he's he or a she, but we know he's somebody who is into business and prepares sausages of different types, that is a Hungarian and also beef, on a daily basis for sale. Excuse me. She prepares at least 40 Hungarian and at least 10 beef sausages. She prepares not more than 160 sausages altogether. Now we know because now they are saying she, so Makwebo is a lady in that case. Okay. So now we are also saying the number of beef sausages prepared are not more than the number of Hungarian sausages prepared. First of all, we need to be acquainted with the terms that are associated to linear programming. When they say, I said linear programming is a topic that is involved with inequalities, and earlier on this morning we looked at how to come up with inequalities of a straight line using either the symbols that is greater than or equal to, less than or equal to. And I did mention this morning to say the greater than inequality will have a broken line if we are to sketch it on the x or y plane. The greater or equal to will have a solid line when it is sketched on the x or y plane. And the less than inequality, which will involve the sign the less than, will have also a broken line. And the less than or equal to will have a solid line. So that's the most important distinction you need to draw from the inequalities that you are going to come up with. So when you come up with the inequalities that are in the question, then you know what is involved. Now, we have been told that we need to acquaint ourselves with the terminologies used in linear programming. When they say at least they are saying is associated to greater or equal to. The other way, they can say more than or equal to. So at least is associated to greater or equal to. Less than or at most is associated to less than or equal to. So you need to be very careful. And in this question, they have used the terms of that nature. At least 40 Hungarian and at least 10 beef sausages and not more than, and all that stuff. So now, having known those terms that are associated with linear programming, now we are going to get the inequalities from the information that has been given and then see if at all we are able to plot it on the x or y plane or the Cartesian plane and find the maximum profit as it has been said when we read the question down there. So allow me now, since we have used the terminology, to go through the question again. This question demands you to understand. There is need for you to comprehend what the question is bringing out. So Makwevo prepares 2 types of sausages, and that is Hungarian and beef daily for sale. She prepares at least 40 Hungarian and at least 10 beef sausages. She prepares not more than 160 sausages altogether. Then the last part of the questions or the statement states, the number of beef sausages prepared are not more than the number of Hungarian sausages prepared. So, part A of the question states, given that X represents the number of Hungarian sausages and Y the number of beef sausages, write 4 inequalities which represent these conditions. So where are we going to get these inequalities? And whenever students look at such questions that are more information, they just give up and say, where are these inequalities coming from? They are just within the question that has been given. So you don't need to bother much as things are going to be very well. So we have been told that X represents Hungarian sausages and Y represents beef sausages. Okay? Y represents beef sausages. So now they are saying she prepares at least 40 Hungarian sausages. So our first inequality is X. We said at least is associated to greater or equal to. So at least 40 Hungarian sausages. So I'm sure we are following there. X is greater or equal to 40. That is the first inequality that you have come up with. Then also, and at least 10 beef sausages. Beef sausages, well, the letter Y stands for beef sausages. So we shall say inequality number 2 will be Y is greater or equal to 10 beef sausages. This is the inequality number 2. The third inequality, because we've been asked to find how many inequalities, they say we need to pick the inequalities that are in that question. So the next question is saying, she prepares not more than 160 sausages together. So meaning Hungarian sausages and beef sausages together, they were not exceeding 160, not more than. So we are saying when you add Hungarian sausages, which is X, plus beef sausages, which is Y, it's not exceeding the 160. So we are saying less than or equal to 160. So you can see how we are coming up now with these these inequalities. Then the last one states the number of beef sausages are not more than the number of Hungarian sausages. This is the fourth inequality that we are going to come up with. The number of beef sausages are not more than the number of Hungarian sausages. So how is this inequality going to be? Beef sausages is Y. It should be less or equal to the number of Hungarian sausages, not more than. So it could be less or equal to the number of Hungarian sausages. So we've already come up with the 4 inequalities. And when you look at the question, the way it appears, it's very difficult to extract these inequalities from the question if at all you do not understand what really the question is asking us or asking you to do. Right, now we have the 4 inequalities there, and then it is very possible now that with the inequalities given, we can draw the graph. We can now put these inequalities on a graph. But first of all, let's look at the question part B. Question part B states that using a scale of 2 centimeters to represent 20 sausages on both axes. This is where also the critical part, where most of the students fail to interpret the scale that has been given. And once you fail to interpret the scale properly, it means we are going to have problems in whatever you are going to do. But here we've been given a guide to say 2 centimeters on the graph papers represent 20 sausages on each and every axis, either on the y-axis or the x-axis. So let me come up with a sketch of this. Please, it's a sketch with yourself. You use a graph and get a ruler, then you draw up nicely the graph what I'm talking about. But we've also been given the range. They have not just left it hanging. They have said, using a scale of 2 centimeters to represent 20 sausages on both axes, draw the x and y axis. Then this also is what confuses the learners or the students. 0 less than or equal to x less than or equal to 160. What does this mean? It is helping you to plan your work properly. It is telling you that the range of the x-axis, it should range from 0 to 160. Meaning, we are not going to position the y-axis in the middle of your graph paper. You need to position it in such a way that you write all the numbers needed from 0 to 160. Of course, bearing in mind that 2 centimeters represents 20 sausages. So we are not going first to draw the x-axis yet. We need first to fix the y-axis. We already have an idea that our x-axis should range from 0 to 160. And also they have continued to say, and 0 less than or equal to y, less than or equal to 160. Meaning even on the y-axis should range from 160 to what? To 0. And each and every 2 centimeters will represent 20 sausages. So that's the information that you need to have. So my sketch is going to be, this is the y-axis. If this is 160, then 20, this is going to be 140. I'm sure you are following me there. And then we are going to have 120 here. Also, we are going to have 100 here. then we are going to have 80 here, then we are going to have 60 here, then we are going to have 40 here, we are going to have a 20 here, and then we can draw the x-axis because now this is going to be our origin. That is simply just a sketch of what is expected of you, and so you don't need to stress. Again, we have been told that the x-axis should range from 0 to 160. So how is it going to be? So here again we're going to have 20, then we have 40, then we have 60, we have 80, we have 100, we have 120, we have 140, and we have 160. So this is how this is going to look like. So having now planned or drawn properly your your x or y plane or the Cartesian plane on the graph paper now puts you in a better position to draw those inequalities that you've been given, because now they are saying, after giving this scale, they are saying, and shade the unwanted region to show clearly the region where the solution of the inequalities must lie. Right, so now let's imagine, I said earlier on, this is a graph paper. So this is, I'm trying to come up with a sketch of a graph paper. We are going to give some good explanation on the same in our next session when you join me. And my colleague also is going to spend some time talking about this. And then we are seeing a graph paper here like this. Okay, it might not be exact, but it's just a sketch so that you can have an idea of what I'm talking about. So when you get yourself a graph paper, try to plan it and demarcate it in this manner. It's going to look something like that. Sorry, this is passing through there. Right, so now we are going to plot the inequalities. I said that the first one is x is greater than or equal to 40. Let's go to the x-axis. This is the x-axis. Earlier on, I said greater than or equal to 40. It means if you're using the greater than, the line will be a solid line and not a broken line. So where is 40 on my x-axis? It is here. So I'm going to draw, this is the line 40, passing through 40. And I'm going to name it as x is greater than or equal to what? 40. Okay. Now, we always shade the unwanted region. When you look at this line, the greater part of this line is to your right-hand side. So the unwanted region is the region that will be on your left-hand side. So this is what we are going to shade, because there is a condition there to say, shade the unwanted region to show clearly the region where the solution of the inequalities lie. So we have shaded the unwanted region is the less than part. The inequality is telling us to leave the required region, which is x greater than or equal to 40. So this can go up to here, it doesn't matter, but we just shade this and see how far we'll go. Right, the next inequality is y is greater than or equal to 10. We go on our graph. This is the y-axis, which you have seen, I've already drawn it. And this is the origin, which is 0, and this is 20, meaning 10 will simply be the middle part here. You'll be able to count on your graph papers 1, 2, 3, up to you reach 10. So this is going to be a line drawn like that, going up to that. But what does the equation or the inequality say? It states y is greater than or equal to 10. So the greater than part is, the wanted part is that one which is going up. So we always shade the unwanted region, and the unwanted region in this case is the less than part, which is this part. Right, so I hope you're able to follow nicely there the shading, but we are going to give more insight on how to use the graph next time in our next session. So this is the inequality, which is represented by the equation y is greater than or equal to 10. Now we are remaining with another two inequalities. X plus y less than or equal to 160, and the other one, y is less than or equal to x. But we can easily draw this inequality before we draw this one, because this is simply an equation of y equals x. The equation y equals x is the one that passes through the origin and slants from top right to bottom left. But some people may not understand that this is a basic equation that slants from top right to bottom left, and it passes through what? Through the origin. Fine. We have y equals x. If we come up with a solution box, we are going to have this situation. This is x and this is y. So I hope you'll be able to follow. We pick on arbitrary numbers, for example, 0 and 1 and 2. Mind you, only 2 or 3 points are important for you to draw this. So when x is 0, what will be y? This 0, we replace it here. We find that y is going to be 0. So y will be 0. When x is 1, what will be y? Where there is x, we replace 1. So we say y equals 1. So when x is 1, y is 1. Interesting. And again, if we replace 2 wherever there is x, y equals 2. So when x is 2, our y is also 2. So we have these coordinates which can be written as 0 and 0, and 1 and 1, and 2 also, and 2. We can now plot these points on the x or y plane. But now, since the graph or the question is asking us, they have given us a scale to say 2 centimeters represent 20 units. We can even do much better by saying we have 0 and we have 20 here, so that we can have 20 there. And if we have 10 here, it means we're also going to have 10 there, so that we can make things easier on the graph. So sketching this on the graph, 0 and 0 will be this point here. I hope you'll be able to see that my 0 is where? My 0 is somewhere here. 0 and 0 will be this point. Right. Then 10 and 10, which is 10 and 10 here, and 20 and 20. 10 and 10, from 0 to 20, the middle part is 10, and the middle of this is the line which we have already drawn. So, sorry, the 0 is going to be here. 0 and 0 here. Then the 10 and 10 will be somewhere there. Then 20 and 20 will be somewhere there. So now you get your ruler and draw a straight line passing through the origin, passing through this part and going up there. So we have the inequalities, this inequality and this inequality. So now what are they saying about this inequality? Less than or equal to. The less than or equal to part is the area under the line that we have drawn. This is the required region. We always shade the unwanted region. So we are going to shade this upper part here so that you can simply follow nicely. So this is what we are going to do. So we have now this position, this part and this part. Now we are remaining with one more inequality which we need to what? To draw on the x or y plane. And this inequality is x plus y. X plus y. Is it less than or equal to? X plus y, yes, less than or equal to 160. You don't need to worry again here. We've already learned how to plot graphs of linear functions or linear equations or linear inequalities. We simply make y the subject of formula. So we have y is less than 160, then minus x. And say, come up with a solution box again. 2 points or 3 are enough. This is x and y. When x is 0, what will be the value of y? When x is 20, what will be the value of y? So when x is 0, we are going to substitute here. Y is going to be 160 minus 0, which is just 160 here. And when x is 20, we are going to say y equals 160 minus 20, and this is going to give us what? 140. So now we have the coordinates 0 and 160, and 20 and 140, and these coordinates need to be plotted on the same graph that we have plotted. So what is 0 and 160? 0 and 160, this is 0 and 160 to be this point here. Mind you, this is the point there. And the other point is 20 and 140. So this is 20 and 140 is this point. So now we are going to get a ruler and draw a straight line passing through those 2 points. I hope we are able to follow, and like that. They are saying this equation is less than or equal to. So meaning the unwanted region that we need to shade is this whole part. So the solution of the unshaded region now lies between this point, this point, this point, and that point. I hope you're able to see clearly. I'm going to make it thick so that you see where the solution is going to lie. Okay, so these are the positions. We have sketched the graphs of the inequalities. Now we are remaining to answer the other 2 questions which are remaining. Question part C. Now that we have sketched this, allow me to create some space here by trying to get rid of this, because this information now, we may not need it. We are winding up now so that we can now be able to finally answer the question as expected. Right, so now what are we saying? We are saying now we need to answer question part C. Question part C reads, the profit on the sale of each Hungarian sausage is 3 kwacha, and on each beef sausage is 2 kwacha. Then they are saying, how many of each type of sausages are required to be prepared to make maximum profit? I hope you're able to see the question that I'm reading on your screen. Then we are saying the profit on the sale of each Hungarian sausage is 3 kwacha, and on each beef sausage is 2 kwacha. How many of each type of sausages are required to be prepared to make the maximum profit? Makwebo is in the business. Whatever she does, she needs to get profit out of it. So if she's manufacturing or making Hungarian and beef sausages on a daily basis, how many beef sausages is she supposed to make, and how many Hungarian sausages is she supposed to make in order for her to maximize the profit? That is the question which is very cardinal. Even you yourself, when you engage yourself in a business, you need to know, am I making profit or am I making a loss? If I'm making a loss, what should I do in order for me to make a profit? So we are going to come up with an objective function, which is also called a profit function, and we can say P equals, we've been told that for Hungarian sausages, Makwebo is making a profit of 3 kwacha. So we shall say 3x plus. For beef sausages, Makwebo is making a profit of 2 kwacha. So we'll say 2y, because we've already ascertained that beef sausage is represented by y and Hungarian sausages is represented by x. Great. So now we are going to move on. How are we going to ascertain this profit? This profit is going to be ascertained on the corner points of this unshaded region. There are so many ways you can find this profit. Others will tell you can use the search line method to find the profit, or you can use the corner point principle. And in this case, I'm going to use the corner point principle to help you find how much profit Makwebo should, how many sausages of Hungarian or beef sausages she should make in order to maximize the profit. So when you do the reading properly, this point here has the coordinates which is 40 and 40, 40, 40. That's the point here. And we have another point here which has the coordinate 40 and 10. I hope you're following. Then we have also the coordinates here at this point. This coordinate is 80 and 80. So 80, 80 there. Then we also have this coordinate here where this graph is intersecting, and this coordinate is 150, 10. Yes, I think this is 150, 10. 150, 10. Right. So now we are going to use these corner points now to ascertain the maximum profit. So how are we going to do it? Let's do it this way. We have already come up with a point to say on the coordinate 40 and 10, what will be the profit, and the coordinate 40 and 40, and also on the point 80 and 80, and the other point is 150 and 10. And 10. These are coordinates, or these are points. Where is she making a lot of profit? Mind you, this is X and this is Y. Wherever we see X, we are seeing Hungarian sausages. Wherever we see Y, we are seeing beef sausages. So now these points are going to be replaced in the given profit function in order for us to ascertain where this Makwebo is having a bigger amount of money. So when we replace there, 3 times 40, this is X, we replace it here, 3 times 40, and we are going to say 3 times 40 plus 2 times 10, because the value there is 10, so we are going to have 140 kwacha. Meaning, if Makwebo manufactures 40 Hungarian sausages and 10 Hungarian sausages, is going to make a profit of 140 kwacha. So we move on again. If we replace 3 and 40 also, plus 2 and 40 again, what is she making? So you find that she's making 200 kwacha here. So if Makwebo manufactures 40 Hungarian sausages and 40 beef sausages, she's going to make a profit of 200 kwacha. Then again we say 3 we replace, that is 80 kwacha, 80 plus 2 and also 80 there. We are going to have a 400 kwacha here, a 400 kwacha. Meaning, if Makwebo manufactures 80 Hungarian sausages and 80 beef sausages, she's going to make a profit of 400 kwacha. Finally, we also test another point, which is 3 and 150 plus 2 and 10. What is he going to make? He's going to make, let me do it again, 3 and 150. Yes, 3 and 150 plus the other one is 10 and plus 2 and 10. So we have 470 kwacha. Now look at the amounts which, the first one, if Makwebo makes 40 Hungarian sausages and 10 beef sausages, she will make a profit of 140. If she makes 40 Hungarian sausages and 40 beef sausages, she will make a profit of 2. So where is she having a bigger amount? That is the maximum profit she's going to make. But the question states, if we get back to the question, part C, let's get back to the question together. Part C states, the profit on the sale of each Hungarian sausage is 3 kwacha, and on each beef sausage is 2 kwacha. How many of each type of sausages are required to be prepared to make a maximum profit? So when you look at when we get back to the working, we have 140, 200, 400, and 470. Where is 470 kwacha, the maximum profit occurring? It is at 150 and 10. This 150 and 10 represents the number of sausages. So we are saying, part C of the question, we can say, therefore, Makwebo needs to manufacture, he needs to make 150 Hungarian sausages, and 10 beef sausages. It should be a sentence, a statement, make 150 Angaran sausages and 10 beef sausages to maximize the profits. So that is how you are supposed to extract the information which is given from the given question and be able to extract it. Question part D, we've already found it because they're just asking us to calculate the maximum profit. So what's the maximum profit? When you go to the calculation there, the maximum profit is already ready, which is 470 kwacha. So that marks our presentation for today. I hope you have enjoyed being with us. Please, we are here to help you revise for your final exams. Thank you so much to Solomon Njovu, who is also very happy. Shambwe Maxwell, Innocent Monga also has joined us and is asking when will be the next session. Yes, the next session will be tomorrow. My colleague will be able to take you through some exam past papers to help you prepare adequately. So please sit back also wherever you are, tag your friends and family members so that they can join us on MTN Teleschool. Once more, my name is Anton Samanenga, and I've been with you today to run through most of the past papers that were written last year, paper 1 and paper 2. So until then we meet, please bye and enjoy yourself and pleasant evening.
Oh, tiende pamozi ni mtima umo, 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 tiende pamozi